Hello everyone, welcome to the course Information Theory and Coding. In the earlier classes, we studied about the digital communication block diagram, and also we discussed about some of the basic information what we are going to process in the information theory and coding through the use of this block diagram. Okay, so you can see here we are mainly focused on in this diagram, that is the information source. So generally the information source will be representing in the form of source alphabet. We will be representing in the form of S only. So it produces certain finite number of symbols. So we are going to represent those symbols in the form of S1, S2, certain q number of symbols. And these sources or these symbols will be produced with some distinct probability values, and those probability values we will be representing in terms of P1, P2 and PQ respectively for the symbols S1, S2 and S3. Now what the source encoder will does is, so it will convert the probabilities values into zeros and ones if you are going to use for the binary channel. If you're using some other channel other than the binary channel, let's say the ternary channel, then we are going to convert these probable values into zeros, 1 and 2. Means we do the conversion from the source alphabet to the code alphabet what it has been produced by the source encoder. And after source encoder, what we do is we will pass the same through the communication channel. So the communication channel, what it does is, because of the nonlinear characteristics in the communication channel, some noise effects will be added to the signal, and this noise effect has to be identified at the decoder for the successful reception of the given signal. And what this source decoder will does is, it will convert the binary outputs into a symbols, source symbols with the probability values as source symbols it will be converting. Okay, so these are the things what we have learned in the yesterday in the earlier classes. Now in the today's class we are going to learn one more important factor or one more important concept in the form of information theory and coding, and that concept we call it as a measure of information. So basically what you mean by measure of information? So as the name suggests, measure of information is nothing but the amount of information what we are going to get from the source. So generally source will generate, as we discussed in the earlier block diagram, generally the source will produce some finite number of samples or finite number of symbols. So let's say we have a source alphabet S which produces the symbols S1, S2 and SQ, and these sources produces with the probabilities values which are represented with a P is equal to P1, P2 and so on up to QQ, PQ respectively. So now what it is, our main job is to identify what is the amount of information which will be conveyed by each symbols we need to understand. So in order to understand this measure of information, I would like to give one of the fundamental or one of the famous example what it has been given in your textbook is that, one of the simple example is, let's say we are planning to have a trip for the Rajasthan. Okay, so along with the faculties and along with the students we want to plan for the we may go with the friends. So let us think that we are planning to have a trip for the Rajasthan. So now if we are planning to have a trip for the Rajasthan, means generally we will be checking so what are the belongings we need to take, and what is how we are going to reach there, and what are the persons we need to contact them, so that all the places, what are the important places are there we need to visit. So all those planning we will be doing. So along with that, as a interest, means we want to make the trip is very famous. What we want to do is we want to make a note of what will be the weather conditions in the Rajasthan and during our the journey we want to see. So in order to see the weather conditions, now what I will do is I will go onto the Google and I will check it out, the environment or the weather conditions in the Rajasthan on the couple of days where we planned for the trip. So if I see that, and so some instructing some three important messages I have arrived. Let us assume that the three important messages I have arrived from the Google. So what are the important messages? The average temperature over those period, let's say it is 38 degrees Celsius in the Rajasthan. So that is one of the information what I have got. And one more information what I have got is, there is a possibility of heavy rain over those period. So that is a one more information I have got. And one more interesting information, let's say what I have got is, there is a possibility of rain snowfall in the Rajasthan. Okay, so now let us think that we have three informations. Okay, what are the information we have? One is the average temperature in this period is 38 degree, and the second one is there is a possibility of the heavy rain, and the third one is there is a possibility of snowfall. That is the three information what we are going to get. Now let us try to evaluate, or let us try to understand. So what is the amount of information we are going to get, or what is the amount of information we are going to gather from these messages, three messages? Let us try to look at. So the first one, what we say is the average temperature over the Rajasthan. We said during the journey time it is 38 degrees Celsius. So generally in the Rajasthan means, definitely the temperature will be more than 35 only. So means what, if I say this or if I read this information from the Google, means then I will not be feeling so much interested. Why? Because yes, it is a known fact in Rajasthan generally the temperature will be more. It is generally greater than 36 degree only, we can say that. So I will not feel interested in reading these messages. Why? Because the probability of occurrence of this message, or the probability of occurrence of the temperature in the Rajasthan is generally it is quite common, that is the probability will be more. So therefore what I am expecting is the information will be less, means based upon the information only I am telling it is less. The next, let us take about the next one. So what I said, the second message is there is a possibility of heavy rainfall. So this is very interesting. In Rajasthan, generally the rainfall will be very low or very less. Okay. So if I see this message, means then I am little bit excited. Why? Because in Rajasthan there is a less amount of rainfall will happen, but during our journey time there is a rainfall is happening. Means okay, I feel interested. Okay, I'm okay. This might be very interesting, or we feel that okay, this trip might be very interesting, very joyful, we can think. And the third message you can see here, the third message what I said is in Rajasthan there is a probability of snowfall is happening. So no, it is not possible at all. Practically it is not possible. Why? Because it is not possible for us to have a snowfall in the Rajasthan. But for the curiosity, let's say if you got, means what we indication, what is the amount of information we get is we are fully excited by looking at this statement. Why? Because possibility of Rajasthan snowfall in the Rajasthan means it is highly impossible, but the Google is saying that yes, it is possible. So means what, the probability of occurrence of the snowfall in the Rajasthan is very minimal. But what is the information we are getting? There is a possibility of snowfall in Rajasthan, means we feel excited, means we have more information, or we need to search more on this. So with the use of these three cases, what we can do is we can have a relationship, the excitement with the probability value. So the first excitement what we had, so the average amount of, that is temperature, it will be 38 degrees Celsius. So probability is high, but the interest or the amount of information it will be less. Means I did not excited, means it is a general fact we assume. The second one what I understood is the average there is in Rajasthan there is a heavy rain is happening during those time. So means the probability of occurrence of this rainfall in Rajasthan is less. Okay, but the information what I'm getting, yes, I'm feeling interested. Means this journey is very interesting, so we can enjoy this journey. So means what? Probability of occurrence of snowfall is less, but the amount of information what I'm getting is more. So means what? There is some relationship between the information and the probability value. The third case you can see here, what I said, snowfall in Rajasthan, it will never happen. Means the probability is zero. The event of occurrence of probability is zero. But what is the excitement I'm getting? The fullest excitement I'm getting. So means what? The excitement, the information it is more I'm getting, but whereas the probability is very less. Okay. So we need to find out a relationship. So how we can match, whether they are directly proportional, whether they are indirectly proportional, or we can make use of any one of the mathematical operations so that I can find an exact relationship between these, the probability values, with against the information content in the source symbol I need to measure it. So you can search out any one of the mathematical operations. There is only one mathematical operations which will have a relation, perfect relations between the probability values and the amount of information, and that mathematical operations we call it as a logarithmic information. So logarithmic information, and both are inversely proportional to each other. So you can see here the amount of information will be more, the amount of information will be more when the probability value is less. When the probability value is less, this is what we can get. Okay, so this is the relation what we have. Ik, that is the amount of information of a particular symbol, if it is inversely proportional to each other. So if I want to eliminate this proportionality constant, then I should introduce some terminology or the mathematical term, right? So if I want to introduce means, then there has to be some meaningful or some relation should be there with the symbol and the probability value, and that entity is nothing but a logarithmic value. That entity is nothing but a logarithmic value. So apart from the logarithmic value, if you substitute any one of the mathematical operation, this entity will not hold good. This entity will not hold good. So therefore, what we see that the amount of information conveyed by each source symbol will be called as a self-information. This self-information we are going to represent it in the form of k value, that is ik, information, self-information. And this self-information, it is inversely proportional to the probability of occurrence of the event. Okay, so now you can see here, I said snowfall in Rajasthan, probability is 0. So 1 by 0 is infinity, means what? The information is more. Now what I said, in Rajasthan, you have a average temperature is 38 degrees. So the temperature, probability of temperature in Rajasthan is, generally it will be 38 only. So means what? The probability is low. When the probability is low, the information is more. When the probability high, information is less. Okay, so therefore, if I do the relationship between this probability value and the self-information, the log operator is the only one operator which will hold these two relationship perfectly. So therefore, we use this logarithmic scale in order to find the self-information about the given particular symbol. So now here what we have considered is, I have one particular symbol sk, it has been emitted from the source symbol with a probability pk. Then what is the amount of information that I am going to get from this source symbol sk will be the actual amount of information, or I am going to measure in terms of self-information. So how I am going to represent, that is nothing but ik is equal to log 1 divided by pk to the base 2. Why we are representing in the form of base 2 means we want to represent in the form of information in the form of bits. So therefore we are taking it in the form of base 2. So this we call it as a self information. Now you can see here, if the base or the logarithmic is 2 means, then the self information we call it as a bits. If you are representing in terms of base 10 means, then the self information we will be representing, but that information we are going to call it as a Hartley or a decit we call it as. If it is represented in terms of natural log e means, then it is called as a nats. Okay, so this is all about your measure of information. I just want to summarize. So what do you mean by measure of information is, it is nothing but the average amount of information produced by a particular source symbol with a probability pk. That is, if you're considering a probability of emission of source symbol sk with a probability pk means, then the amount of information conveyed by sk will be represented by ik, that is a self information, which is given as log of 1 divided by pk. The log base what you are going to consider, based upon that we are going to represent the information. If the log is 2 means, then base 2 is 2 means, it is called as a bits. If the log base you have used as a 10 means, it is called as a Hartley or a decit. If the log base, if it is a natural log means, then it is called as a nats. The remaining thing we discuss in the next class. Thank you.